is this. Now we'll be doing division of a line segment into in a given ratio, right? That's it here. So sometimes we'll be given a line in midpoint. We found how to find the middle of this line, but now what if this line is divided into two by a given ratio, maybe by 2:3, right? So the distance here and the distance here are in the ratio 2:3, or they could be in the ratio 4:2, something, right? 4:2 means that it will come a little this way, right? Because 4:2, right? So if you are asked to find the point, this point that divides the line segments into ratios, how are we going to find it? So this is how we find it. So let's take this as our line segment AB, right? Then AP, which is here, divided by PB is equal to the ratio in which they are divided. So for the purpose of this lesson, we'll be using lambda and then mu. So lambda and mu. So never forget that lambda comes first, okay? So this is what we'll be using. This is the ratios. The formula for finding the coordinate of P, right? So P has X, and then it has Y. What is the value of X? X is given by lambda x2 plus mu x1 over lambda plus mu. Then Y is given by same thing, this is lambda. Perfect. So this is what we'll be using throughout. So we'll have to memorize it and then write it in our notes and memorize it. And it's very easy. So always lambda comes first because lambda comes first, and then x2 comes first because of lambda. Like they are kind of interchanged, right? So if lambda comes first, then x2 comes first, right? So it's like that. So that's what we'll be using here. And then we'll see those formulas here. Right. So this is the formula we'll be using throughout this section to find the points that divide a line segment into a certain ratio. The same formula applies to both external and internal, right? So we have two types of division. We have external and then we have internal. What's the difference? So if I have a line and I divide it like this with a point P, then this point is dividing these two, dividing this line internally. What of if I have this line, I have A here, I have B here, then I put P here, right? It's still a division, right? Or there's still a ratio between AB, AP, and then BP. There's still a ratio, and then here too we have a ratio. Right? There's still a ratio, just that in this case, the P lies outside of the AB, but we can still find the ratio of their magnitudes. So this is external. just because the point lies outside, and this is internal because the point lies inside, right? So that is it. I think we'll move on with our first example. So let's take our first example, which is example 1. In example 1, P and Q divide the line AB with A's coordinates being given internally and externally in the ratio 3:2, right? So the ratio given here is 3:2. Find their coordinates. So internally and externally. So we'll do first for internally. So if the line divides internally, then the coordinates of internally is P, right? You see the way the question is put. P and Q divides internally and externally. So P divides internally and Q divides externally. So we are finding P. So the x of P, right, will be given by lambda x2 plus mu x1 over 2 over lambda plus mu. So let's see, what's lambda? Lambda is 3. What's x2? X2 is 3 because this is x, this 1, this is 2. You can choose to interchange them, but you make sure that you take note of which one is 2 and which one is 1. So plus mu is 2. Then what is x1? X1 is minus 2, minus 1. So that is x. Lambda plus mu is 5 because it's 3 plus 2, right? Yeah, 3 plus 2. So that's 5. So we have 9 minus 2, that's 7 over 5. So that is the value of x. Now let's see p of y. Lambda y2 plus mu y1 over lambda plus mu. We have 3, y2 is 4 plus mu is 2, y1 is 2 divided by 5. We have 12 plus 4 over 5, that is 16 over 5. Perfect. So the values of p, the coordinates of p are 7 over 5 and 16 over 5. And this is the point that divides the line AB internally in the ratio 3:2. Right. That means that if I draw this AB that we're given here, right, if A is here and B is here and P is here, if you measure from here, and then P is here, if you measure from here to here, right? So if you measure AP, the magnitude of AP, and we divide by the magnitude of BP, PB, then the answer will be 3:2. Right, so that is this for internally. Let's see for externally. If it's external, the only difference or the only thing that changes is that one of our ratios becomes negative. But which of them becomes negative? We always choose the smallest as negative. So let's see. The smallest amongst the ratios as negative. So if I have, right, that is given here. However, for external division, we negate either lambda or mu, that is the smaller of them. So negate the smaller of them. So if we have 3 is to 2, the smaller of them is minus is 2, so we negate it. So externally, so we'll have px being equal to lambda x2 plus mu x1 over lambda plus mu. That is lambda. What's lambda? Lambda is 3. Never forget, it's lambda and mu. So mu is minus 2. So 3, everything remains the same, plus just that now we have negative 2 here. So let me just make it negative, so that makes sense. So we have negative 2 here, then minus 1 over 1 plus 3 minus 2 now. So we have 9 minus 2, that's 9 plus 2, so 11 over 1. So px is now 11. And let's py for externally, lambda y2 plus mu y1 over lambda plus mu. We have 3. What's y2? y2 is 4 minus lambda mu now becomes minus 2 into all over 3 minus 2, which is 1. It's no more 5 because the 2 is now negative, so if you add them it will be 1. So we have 12 minus 4 1, which is 8. So for external division, p becomes 11 8. So that's how we solve them. It's very simple. And then the diagram is shown here. For internal, we see A here, B here, and then P in the middle. But for external, we see A here, B here, and then P lying outside of it. But we can still find ratios in there. So there are several examples here. A, B, and C are points relative. Find A, B. This is a magnitude formula, a magnitude question. The next one is gradients. We've done gradients. In our previous video, we've done midpoints. In the previous video, point P, which divides BC in the ratio, and this is division. Ratios. Right, so we've done pretty much everything this question asks for. So we could try them. Pause the video and try. Just make reference to your textbook. There are more examples here. Look at this question. A, B, and C are points given. Find the coordinates of the points of trisection of BC. Right. So coordinates of trisection of BC. What does that mean? Right. P and Q are points of trisection there. Coordinates are okay. So if a line is trisected, right? So when you bisect a line, you need to divide it into 2, because by its sense that means 2. So when you trisect a line, you need to divide it into 3. So A, B, and C are points. This is A, this is B, this is C. Find the coordinates of the points of trisection of BC. This is B, this is C. So the line is BC. So we have a line BC. We want to find the coordinate of trisection. That means we want to find 2 points. That will divide this into 3 equal parts. So we have this with P and then Q, such that this will be 1, this will be 1, this will be 1, right? Or this will be 1 over 3, this is 1 over 3, 1 over 3, so that the length of each one will be the same. That means that we are dividing BC into 3 equal parts, each of them having 1 over 3, 1 over 3, 1 over 3. But how do we solve such a question? That means that we are dividing the line segment not into 2, but we are dividing it into 3. So P divide the line in ratio 1 is to 2. Then Q also divides it into 1 is to 2. Right, so we divide it in the ratio 1 is to 2, 1 is to 2, right? And then that is exactly what we did here. So the coordinates of P, see, we are dividing by the ratio 1 is to 2, dividing the whole BC into the ratio 1 is to 2, and the coordinate of Q, it's also 2 is to 1, right? So the coordinate of Q here is also 2 is to 1. Then that's all. So we divide it like that, and then we get the answers. So the answers are here. We could cross check. And I find the gradient of TFAB. Right, the question says find the angle BAC. So you have the line BC, and then we have a point A. Find the angle BAC. Angle BAC represents the angle at A. The angle at A. Right, that means it is B, this is B, this is C, this is angle BAC. But how do we find the angle BAC? Right, so we know this one. So from this diagram, you can see that the angle here, right, can be calculated by the gradient of AB, right? So if we find the gradient of AB, then equate it to tan theta, then we can find theta. So the gradient of AB is equal to tan theta, and we are finding theta, right, which is our angle BAC, because that's the angle here, right? So let's see, gradient of AB will be given by looking at the point AB. The gradient of AB will be given by 7 minus 3 over 4 minus 2. This is equal to tan theta. So you can find this is 2, right? So tan theta is equal to 2. How do we find 2? Theta is equal to tan inverse of 2. So we have 60 degrees. So that is the answer here. So you should pause the video and try some other examples. These are very basic and very simple to solve. Right, thank you.